Mathematics intersecting circles. The figure below shows two circles with centers A and B and a radii of 6 centimeters and 8 centimeters respectively. Angles PAB is given as 45 degrees, and angle ABQ is given as 30 degrees. And we have the diagram there, the figure of two intersecting circles. So we have the measurements. AP, it is 6 centimeters, that's the radii, and the radii of the other circle with the center B, the radii, or the radius is 80 centimeters. We have line P and a Q, then we have line A and a B. Find the size of angle PAQ. Find the size of angle PAQ and PBQ. So solution, part A, Roman 1, we need to get the value of angle PAQ. And the PAQ, being given that if this is 6 centimeters, the radii, they are all equal. So it will mean as well, this is 6 centimeters. Because we cannot have a circle with two different radius. As well, this is 8. This being 8, this is 8 centimeters. This is 8 centimeters. This was 6 centimeters. 6 centimeters. So if these triangles, these lines are equal, then to me this angle is equal. So this angle is as well is equal. So this will be 30 as well. This will be 42 as well. So angle PAQ will be 42. Angle 42 multiplied by 2, which will be 84 degrees. That's Roman 1 and Roman 2. Angle PBQ will be 30, equal to angle 30 divided by 2, which will be 60 degrees, and that is 4 marks. Question part B. Calculate the area of the shaded part. So we can get these angles here. Angle PAQ, we have got to be 84 degrees, and angle this was PBQ, sorry for that. PBQ, right? PBQ is equal 60 degrees. That one we have done. So I can create some more space for part B. It's a bit longer. So area of shaded part. Area of the shaded part. And we'll look at this triangle here. I mean, these two intersecting circles. We have triangle APQ, and we have as well, so with the circle with center B, we have triangle PQB. As well, we have a sector from this point AP this way to Q, then back here. We have a sector. So to get the area of the shaded part, what we do, you get the area. Sorry for that. So we get the area of sector minus area of triangle. We have this triangle, this sector that way. Then we go back this way. We have that sector, looks this way. All right. Remember here, this is A, so this is 84. We found it that way. Then the radius here is 6 centimeters. Right. We have this is a segment. So we have this triangle, sector. Then we have this triangle. So we can get the area of the whole sector minus the area of this segment. Then minus the area of this triangle, remain the area of the segment. All right. Then also we do the same with the other triangle, here, which looks like this way. that way. This one here was 60. All right, this is shaded part. This is 80 centimeters, that is 80 centimeters. So these have just extracted this triangle here, this sector. So the area of the sector minus the area of the triangle, it will be the area of this segment, which is this one. All right. So we go to the other sector, the side now. The area of this sector minus the area of this triangle will get the area of this other segment there. All right. Then you add, so we have the two segments, then you add the areas of the two segments. In that case, you have calculated the area of the shaded part. So that's how we approach these questions. Let's do it. Area of a sector, we say it is theta over 360 pi r squared. Pi r squared. So let me get my calculator. Well, so this will be 80. Well, this was what? 42 for 2. This is 84. Come on. This is 84. Right? That's 84. So this is 84 out of 360 multiplied by 22 out of 7 multiplied by 6 multiplied by 6. So the area of that will be 84 multiplied by 22 multiplied by 36. And what you get divided by 2520, that will be 26.4. So this is 26.4 centimeters. Now let's get the area of this triangle. When you have such a triangle whereby you have the two sizes given, the isosceles triangle and a subtended angle, the formula we use to calculate the triangle, this form of triangle is a half AB sin theta. Half AB sin theta. A is one of the sides. A and B, they are the two ready. So you can work it out here. So it will be 1 out of 2 times A, which is 6, times B, which is 6, then sin theta, which is 84. This will be, so by 2, 1 by 2, 3. So that is 3 times 6, that is 18. 18 multiplied by sin 84. You get 17.9. 17.9 centimeters. So to get the area of this segment, it is the area of the whole sector minus the area of the triangle. So it will be 26.4 minus 17.9. The answer you get being 6.4. That you get it is 8.49. 8.49 centimeters. So that is the area of this segment. So we have to do the same to this one. We are going to use the same formula. Area of the sector. You see the formula theta over 360 pi r squared minus the area of the triangle, which is half AB sin theta. So let's do the sector. It's theta over 360. So it will be 60 out of 360 times 22 over 7 times 8 times 8. That will be 60 times 22 times 64. 8 times 8. And cancel it by 25, 24, 25, 20. You'll be 33.5. To be 33.5 centimeters. Then we need to get the area of the triangle, which is a half AB sin theta. So half times B, 8 times 8 sin 60 by 2, 1 by 2, 4. So this will be 32 multiplied by sin 60. What we get? So 32 multiplied by sin 60, and then you get it is 27.7. 27.7. So you get the area of the sector minus the area of the triangle. And what are you getting? Let's do it. 33.5 minus 27.7. You get it is 5.78 centimeters. So this is the area of this sector, 5.78 centimeters. The area of the other sector was 8.4. This one now is 8.49. So to get the area of the shaded part, you add the two. So it is 8.49 plus 5.78, right? So 8.49 plus 5.78, which will be 14.27. 14.27. So the area of the shaded part is 14.27 centimeter squared, right? So that's how it is supposed to be done.